Now we continue with the WASSCE questions on circle geometry, and the next one is from year 2007. That's question 8B. There's a diagram. Let's have the diagram. And the question says, the question is here. In the diagram, O is the center of the circle and ABC is a tangent at B. If angle BDF equals 66 degrees and angle DBC is equal to 57 degrees, calculate Roman figure 1 angle EBF and Roman figure 2 angle BGF. Start with Roman figure 1. How do we find angle EBF? Now, if O is the center of the circle, that simply means EB is the diameter of the circle, and that means angle EDB is equal to 90 degrees. The reason for that is angle in a semicircle. How do you determine that? The angle formed by any two lines that meet at the circumference to form a triangle with the diameter of the circle is the angle in a semicircle. And we can see that ED and BD meet at the circumference to form a triangle with the diameter EB. So the angle formed by those two lines, ED and BD, is 90 degrees, and it is the angle in a semicircle. That's the reason. Now, if EDB is 90 degrees, that simply means we know that this angle is 66 degrees. That means this small angle is 90 minus 66 degrees. The whole of it is 90, and that means the small angle will be 90 minus 66, and that small angle is angle EDF. Angle EDF equals 90 minus 66, which is equal to 24 degrees. And we can see that that angle is the same as this angle. It's the same as this angle, which is the angle we want to find. We want to find angle EBF. Angle EBF is the same as angle EDF. And the reason for that is angles in the same segment. So therefore, angle EBF is also equal to 24 degrees. Now let's see, how do we determine the same segment angles? If I join F to E, then I'm going to have a chord FE. We'll see that lines FD and ED meet at the circumference to form a triangle with the chord FE. And line FB and EB also meet at the circumference to form a triangle with the chord FE. The angles formed by those lines are the same segment angles. So that's a trick for determining the same segment angles. Now, what's the next one? Roman figure 2. Roman figure 2 says find angle BGF. Let me have a diagram again. How do we find angle BGF? If this is now angle BFD is the same as angle DBC, and that was the reason for that. We can see that angle DBC is between chord DB and tangent BC. And there's a theorem that says angle between a chord and a tangent is equal to angle in the alternate segment. And how do we know that alternate segment angle? Is the angle formed by any two lines that meet at the circumference. As we can see here, BF and FD meet at the circumference to form a triangle with the chord BD. Any two lines that meet at the circumference to form a triangle with the chord BD. The angle between those two lines is a alternate segment angle. So this is 57 degrees. And we can see that also applies to BE and ED also meet at the circumference to form a triangle with the chord BD. So that means the angle formed by BE and ED is also the alternate segment angle to 57 degrees. So I can just simply write angle BFD is the same as angle BED, which is the same as angle DBC. And the reason for that is angle between the chord and the tangent equals angle in the alternate segment. So that therefore means angle BFD equals 57 degrees and angle BED also equals 57 degrees. Angle BED also equals 57 degrees. Now, let me make my diagram neater. Now we can see that in triangle BED, in triangle B, let me even call it BDE. In this triangle BDE, in triangle BDE, 57, of course we know that the whole of it is 90. The whole of it is 90. 57 plus 90 plus angle EBD equals 180 degrees. So angle EBD plus 57, angle EBD plus 57 plus the whole of this, which is 90, equals 180 degrees. Sum of angles in a triangle, and that simply means angle EBD equals 57 plus 90 is 147. So that means angle EBD equals 180 minus 147, and that's equal to 33 degrees. Now, how do we find angle BGF? This is angle BGF. How do we find that? That's angle BGF. We can see that angle BGF is an exterior angle to triangle. It's an exterior angle to triangle BGD. And the sum of exterior angle of a triangle, exterior angle of a triangle is equal to sum of opposite interior angles. So that means angle BGF. That means this angle BGF is equal to 66 plus angle EBD. And we just found that to be 33 degrees. Angle EBD is 33 degrees. So I can just say angle in triangle BDG. This is a triangle, I mean BDG. In triangle BDG, angle BGF, which is an exterior angle to triangle BDG, is equal to 66 plus 33. Let me check that again. Angle BGF, which is this red angle, is equal to 66 plus 33. The reason for that is the exterior angle of a triangle is equal to the sum of opposite interior angles, and that's equal to 90 degrees. So angle BGF is equal to 90 degrees, and that's it, very, very simply. Thank you very much, and I'll see you in the next. Bye bye.